The dominance of Amazon Web Services, Microsoft Azure, and Google Cloud Platform in the cloud computing market isn't accidental, it's the result of years of massive infrastructure investment, ecosystem development, and enterprise trust building that smaller or traditional hosting providers simply haven't been able to match. When companies, startups, and developers choose between these hyperscalers and alternatives like DigitalOcean, Hetzner, Linode, or self-hosted bare metal servers, the decision usually comes down to a combination of scalability, reliability, breadth of services, global reach, and the peace of mind that comes from using a platform that millions of other organizations already depend on. The single most compelling reason people gravitate toward AWS, Azure, and GCP is the ability to scale instantly and elastically. Traditional hosting, whether that means renting dedicated servers or running your own data center, requires you to forecast your capacity needs in advance, procure hardware, wait for it to be provisioned, and then manage it yourself. If traffic spikes unexpectedly, you are either over-provisioned and wasting money, or under-provisioned and crashing under load. The big three solve this entirely. With a few API calls or clicks, you can go from running to servers to running 2000 and scale back down just as fast. This elasticity is genuinely transformative for businesses whose traffic is unpredictable, seasonal, or growing rapidly. Think e-commerce platforms during holiday sales, streaming services during major live events, or startups that suddenly go viral. Closely tied to scalability is the pay-as-you-go pricing model. Instead of signing multi-year contracts for physical hardware with large upfront capital expenditure, cloud customers pay only for what they actually consume: compute hours, storage gigabytes, data transfer, API calls. For early-stage startups, this dramatically lowers the barrier to building and launching products. For enterprises, it converts infrastructure from a fixed capital expense into a variable operational one, which gives finance teams more flexibility. That said, this pricing model cuts both ways. Cloud bills can spiral unexpectedly if teams aren't careful about egress fees, idle resources, or runaway autoscaling, which is one reason some companies eventually repatriate workloads back to owned hardware once their usage stabilizes and becomes predictable enough to justify the upfront cost. Global reach is another area where AWS, Azure, and GCP are in a different league. AWS alone operates dozens of geographic regions with multiple availability zones each, meaning you can deploy your application close to your users whether they're in Mumbai, Sao Paulo, Frankfurt, or Sydney. This reduces latency, improves user experience, and in many cases satisfies data residency regulations that require customer data to remain within certain geographic boundaries. Smaller hosting providers typically operate out of a handful of data centers, which makes global distribution either impossible or requires cobbling together multiple vendors, adding complexity without the integration benefits of a single platform. The managed services ecosystem is perhaps the most underappreciated reason why developers and organizations stay loyal to the big three. It's not just that you can rent virtual machines, it's that you can also get managed databases that handle backups, failover, and patching automatically, serverless compute that runs your code without you ever thinking about servers, message queues, object storage, content delivery networks, identity and access management, machine learning platforms, monitoring tools, and hundreds of other services, all deeply integrated with each other and all maintained by the provider. GCP's BigQuery, for instance, is a fully managed data warehouse that can query petabytes of data in seconds without you managing any infrastructure at all. AWS SageMaker provides a complete machine learning workflow from data labeling to model deployment. Azure Active Directory integrates directly with Microsoft 365, making enterprise identity management largely seamless. Building equivalent capabilities in-house or stitching them together from independent vendors would take enormous engineering effort. Reliability and uptime are also central to the appeal. The Big Three publish service-level agreements promising 99.9% to 99.99% uptime for most services, backed by redundant architecture across multiple physical facilities. If one data center loses power or experiences a hardware failure, traffic automatically reroutes to another availability zone with no manual intervention. For a hospital, bank, or large retailer, even a few hours of downtime can mean millions in lost revenue or patient risk. The hyperscalers' redundancy guarantees are worth a significant premium over cheaper alternatives that don't offer the same resilience. Security and compliance certifications are a major driver, particularly for regulated industries. AWS, Azure, and GCP hold an enormous number of certifications: SOC 2, ISO 27001, HIPAA, PCI DSS, FedRAMP, and many others, which means companies in healthcare, finance, government, and other regulated sectors can use these platforms and inherit a significant portion of their compliance posture rather than building it from scratch. Azure in particular has made deep inroads in government and defense markets, partly because of its FedRAMP authorization and specialized sovereign cloud offerings. Finally, there's the talent and ecosystem network effect. Because AWS, Azure, and GCP are so widely used, there is an enormous pool of engineers, architects, and DevOps professionals who already know these platforms. Hiring is easier, onboarding is faster, and there's a vast library of tutorials, open source tooling, community support, and third-party integrations built specifically for these environments. Choosing a less common hosting provider can mean your team spends more time solving infrastructure problems that the broader community has already solved on the major clouds. That said, alternatives absolutely have their place. Hetzner and OVH offer bare metal servers at a fraction of the cost for workloads that are stable and predictable. DigitalOcean and Linode provide simpler, more transparent pricing that suits small teams and individual developers who don't need the complexity of AWS. Cloudflare Workers and similar edge platforms offer compelling alternatives for specific use cases. The honest answer is that AWS, GCP, and Azure win on breadth, maturity, scale, and ecosystem, but they are genuinely overkill for many projects, and the savviest engineers know when to use them and when not to.